Okay. So let's take a look at this first at these proofs. So look at number one. All right. So you're given that angle one and angle two are congruent. You're also given that AD and BC are congruent. Those are what's given to you. Now, if those are congruent, okay, if one and two are congruent, you know here that you have AD and BC end up being parallel by the converse of alternate interior angles theorem. Okay, that's one way of doing this. And then you have ABC as a parallelogram, because if one pair of sides is congruent and parallel, then the shape is a parallelogram. Okay, so now a lot of you probably went right to triangles, right? All right, I probably would have too if I was looking at this for the first time. So here's what they're giving. Now, if I mark this would be congruent with this. This would be congruent to itself, right? And then I'd have these two angles congruent to each other. So you know these two triangles are congruent by side angle side, right? And you can definitely prove parts, but you'd still have to go back for the parallel part because it's a parallelogram, right? You have to have one. That is like a big thing with parallelograms. You have to have one pair of sides congruent and parallel. Once they're congruent and parallel, you're done proving it. Okay? So you could still do the CPCTC stuff. It's just not going to do you much good for this one. Yes?
Wait, so what is the converse?
That's where you're proving lines parallel, not angles. Remember? Remember back from topic 2. If you're given angles and you need to prove lines, you use the converses. If you're given lines, you need to prove angles, you just use the straight theorems or postulates. Okay? So good review for the final exam. All right, questions on that one? All right, let's take a look at number 2. So it says given FD is congruent to EB. So if you want to mark it, so we're going to have F to D. So this, let's see, where is it? This guy right here is congruent to this guy right there. Okay. AF is congruent to CE. So AF is right here. CE is right there. And the angle AFD is congruent to CEB. So AFD, this guy right here, is congruent to CEB, which is right there. Okay. So given this fact, you have this side, you have the angle, you have everything you need to prove that these two triangles are congruent by side angle side. Once you are done with that, now remember, we're trying to get everything they've given us is inside this quadrilateral, right? We need things that are outside. So there's a good indication that you need to use CPCTC here. If it's inside, you got to work your way out. You're probably going to prove triangles. If it's outside and you're kind of working with some things inside, you're probably proving lines parallel. Okay. And you might not need CPCTC. So just kind of keep that in the back of your heads. All right, so in this case, we're proving that I'm just going to get a different color. AD is congruent to BC, and that's by CPCTC. Now you have, if that's the case, you also have angles that are congruent to one another. In this case, I chose ADF. So here's A to D, ADF. So this guy right here, okay, is congruent with CBE. So here's C to B to E, all right? So you have right here, here is your parallel line, here is your parallel line, here is your transversal, okay? And so both of we got the congruency and at least the angles to show that these two are parallel by CPCTC. We know that AD is going to be parallel to BC by the converse of alternate interior angles theorem. Sorry, it's kind of in reverse there, but. And then you know, because you have opposite sides congruent and parallel, then it has to be a parallelogram. Now, I do have other proofs that we're going to go over. I might start just incorporating those as a little bit of a warm up. Okay. So that we're a little bit more ready for the test. But this isn't the only one we're going to do. Okay. This is just the beginning. All right. So hold on to that. And if you're still writing it down, that's totally fine. I'll give you a minute. And then when you're done, take out your companions and your foldables, please. Oh, you two are still feuding, are you? Okay, just checking.
Oh, he's been.
There's none up there? All right. In your companions, please turn to page. We're gonna start at 154. I'll do the backside on your own a little later. Okay, so conceptual understanding. We're going to add this definition and property to workbook. If you want to add it, I think it should be on your foldable, but double check. So investigate the angles formed by the diagonals of a rhombus. So a parallelogram ABCD is a rhombus. What are the measures of angle 1 and angle 2 and angle 3 and angle 4? So in this case, all four sides of a rhombus are congruent. And another thing is, for a rhombus, this is basically a parallelogram with four congruent sides. Okay. So if you looked on your foldable, okay, and you looked, it says properties of parallelogram, and then it says a parallelogram is a blank if, right? In this case, you're looking at a parallelogram is a rhombus if, all right? And if you open that up, it says all sides are equal, diagonals are congruent, and diagonals are perpendicular bisectors. So if all the four sides are congruent, now this rhombus still contains all the properties of a parallelogram, but we're adding into it these three additional. Okay. So right now it looks like a rhombus has a total of 7 properties according to our foldable. So in this case, if we look, if all the four sides are congruent, we're talking about angle 1, 2, 3, 4, and we just looked at our foldable and said, hey, diagonals are perpendicular bisectors. What do we know about angles 1, 2, 3, and 4? They're what? They're right angles. Yep. So a rhombus is a parallelogram, so it has all the same properties of parallelograms. Diagonals are perpendicular bisectors of each other, so therefore these have to be right angles or 90 degrees. Okay? Questions on that? All right, looking at letter B. Parallelogram JKLM is a rhombus. How are angle 1, 2, 3, and 4 related? So if we take a look at this, it says by side, 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 JKL is congruent to JML. So angle 1 and angle 2 are going to be congruent, along with angle 3 and angle 4. The other way you could have really looked at this also is that if these are isosceles triangles and you know these angles, you would know that these would also be the same, right? Because opposite angles end up being congruent. So in this case, the property of a rhombus bisects the angle at each vertex. All right, so that's the other property. I think that's one diagonal of a rhombus bisects the angle at each vertex. All right, so that's one thing that is not on there if you want to put that in. The diagonals of a rhombus bisect the angles at each vertex. You can add that to your foldable if you want. That's one that's not in there.
Yeah, we were
What's up? Everything okay?
Yeah.
Oh, did I okay. Just checking.
Oh yeah, the test. That's what it was. I didn't turn my
Yeah, if you didn't put in that, put the quiz stuff right over there right now. Because I am going to grab that. Evan, are you good? Evan? Evan. I said it. Okay, Evan. Hey, are you good?
Yeah.
Okay, I called your name like 5 times.
Oh, did you?
Yeah, at least.
Oh,
Okay, I was just making sure that I'm like, I am. And then, like, I'm thinking to myself, am I screwing up a name? But I wasn't. I was good. No, I just want to make sure you turned it in.
oh yeah.
Okay, good. Over there.
It's like a stapler because I printed it on
Stapler?
Yeah, I printed it on at home.
There you go. All right, let's take a look at this. All right, so we're in our Try It workbook, page 154. So they're saying here, what is WY? Now, the first thing we need to kind of discuss or review is the Pythagorean theorem. All right. Pythagorean theorem. Now, I know you guys are used to the traditional a squared plus b squared equals c squared, but I'm going to change this a little bit for you because ABCs are harder to identify. We're going to change this to leg squared plus leg squared equals hypotenuse squared.
That's not my
No, it's not. Exactly. Exactly. This whole ABC thing, I've always hated it. It doesn't identify diddly. So in this case, if you have leg squared and a leg, you guys can identify, or at the very least, the hypotenuse, you know where those pieces are. Yes, Evan. You use the bathroom. All right, so leg squared in this case. Now, if you take a look, they want us to find WY. Well, we don't have WY, but we do know that these diagonals bisect each other. So this has to be 3. So which means if I did leg squared plus, I'm going to label this with an X real quick. Leg squared plus leg squared equals hypotenuse squared. This is going to be 3 squared plus X squared equals 5 squared. Someone tell me, what does X equal? Good. X squared? Or X, I mean. Yeah, the whole thing. Yeah, 5 squared is 25. I agree with that. Yeah.
16.
It would be X squared is 16.
Oh.
So that means X would be 4. Yes.
Well, I got X before, but I didn't get X squared.
I'm trying to make it I know that yesterday.
There you go. All right. So that means that W, now that means that WY, why didn't my color change? There we go. WY is going to be 2 times that 4, which makes it 8 total. Okay. Okay, so there's a couple of properties for letter B we can use. So it says, what is the measure of angle RPS? So we're talking about R to P to S. Now, this is a rhombus. We know it's a rhombus because all of these are congruent. Okay. So that means it also shares the properties of parallelogram. So if that's 70 degrees, this is also 70 degrees. But we also know that those diagonals kind of bisect the angles also. A lot of different rules you guys have here, right? Thank you. All right, so the other thing you can look at is this is an isosceles triangle. So I'm going to take 180 minus 70, which leaves me with 110. I'm going to divide that by 2. I get each angle is 55 degrees. So then in this case, we know that the measure of R to P to S is also 55 degrees. Questions on that so far?
Hypotenuse is like the opposite. Is that's a leg, that's a leg, that's a leg. It's like the opposite. She's told me to shut up this whole day.
All right. So the rule of thumb here, guys, the legs create the 90-degree angle. The hypotenuse, you can physically draw an arrow from the 90-degree angle to the hypotenuse, like across it. So if it's right here, there's your hypotenuse. So then you know the other two have to be legs. All right. Questions on this? All right, let's take a look at example 2. All right, so quadrilateral ABCD is a rhombus. What is the measure of ADE? So AC bisects angle BAD, so the measure of angle DAC is 53 degrees. So now the question here is, what is the measure of ADE? Well, the measure of ADE is just going to be 180 minus 90 minus the 53, which should leave you with 37 right there. Or ADE, sorry. Should be right there. Now, in this case, quadrilateral GHJK is a rhombus. So they're telling you it's a rhombus. What is GH? Okay, so in this case, we know diagonals bisect each other. So I'm going to set these equal to each other to get x equals 5, and then I substitute that in. In this case, I'm going to get GH is equal to 16. So now if we take a look at example 2, each quadrilateral in this case is a rhombus. They're telling us what is the measure of MNO. So here's M to N to O. So they're talking about this entire angle right here. Well, the best thing to do is to look at this part. So we have 62. We know these are perpendicular bisectors. So that's 90 degrees right there. We can find the measure of angle MLO. So this will be the measure of angle LMO will be 180 minus 90 minus 62. What does that give me? 28. Now, if this is 28, we know that this is LN is a bisector of this entire angle. So I'm going to take that the measure of angle MLO is going to be 2 times 28, which leaves me with, in this case, how many degrees? 56. And we know opposite angles are congruent, so that the measure of angle MNO is equal to 56 degrees. All right, for letter B, what is QT? They want you to know this whole thing, but what do they give us here that we can actually work with? Go ahead. They are. So in this case, this is congruent with this. So this will be 3y minus 1 equals 2y plus 3. Someone tell me, what does y equal here? Cassie? 4. Substitute it in. We get QS, which is going to be 5 times 4 minus 4, which is 16. And then we need to divide that by 2 because they're only asking us for this part right here. So QT is equal to 8. Questions on that? Izzy, are you okay?
Yeah.
Are you sure?
Yeah.
Sure. Any questions? Okay. I want you guys to turn to page 156. I want you to work on 3, 4, 5, 6, and 12.
She was an alien, and I was a pilgrim.
Oh, that's so cute.
Probably Is that actually what you told her? No. My mom was like, I found your pilgrim costume. Oh, and I was fine. To be a pilgrim. I don't even know that. I think I was a bunny that year. Or maybe I wasn't. I was a bunny that year.
I'm sorry?
Oh, I remember that. There's definitely a picture of us.
All right, remember, you are working on 3, 4, 5, 6, and 12. Work on those real quick.
here.
It would have been more criminal.
15. That's like she's almost.
Basically,
Round to the near side.
I've got that people close. Like also
I got 23. Oh wait.
no, example 3.
No, it's 28. Wait. D, F, G. How'd you know that? That's
No, it's not.
That's D, F, G. That's D, F, G. They should be
Yeah, no, it's not. It's
D,
not.
but it's F, G. Yes. E, F, G is the whole thing.
Diagonals do not make that easy.
D, F, G is the whole thing.
So it's not right.
It's half. What? Oh, I'm on the wrong. D, F, G.
It's a rectangle, not a
No, we're
line.
not on the wrong page. It's D, F, G. The whole thing. No, it's half. No, they're on that page.
So we got a dog.
No, D, F, G. It's half. This
That's
was half. Yeah.
We're supposed to be on 156. Page 156.
Why are you telling me to whimper like a little kid?
I don't have high energy. Feel sad.
Oh,
Just
that's
did it. Isn't that literally? I don't know. I can find. I don't know. Actually, no. Does it say the diagonals? D.
No, it's like.
Wait, guys, what? That is not 10. No way. Trust the picture. No way that's 10. Don't trust the picture. It can't be. Don't trust the picture. Because it says diagonals. Wait, are figure in, but that's not right. Yeah, that's right.
That's how GF
But this is not.
That's so wild.
Oh, you're right. You're so right. But
That's
don't
weird.
trust the picture.
Yeah, his persona is dope.
Okay, now we're done. No, we have to do 3.
That's crazy. Like even I'm not that. You know I'm not. Wait, why is it not referencing?
That's actually really cute.
No, I was never the
Yeah, and then
I'm not even close. You remember Halloween?
that
Remember Halloween? The one girl that came into our class in ELA?
How we doing, guys? Thumbs up. We're doing good. How many of you are done with up to 6? Okay, so we just have 12 maybe to finish up?
Yeah.
Alrighty.
I thought you were.
It's
And how do you even know that?
it's this. Okay,
How do you
since
know
these
someone
two
else's words way better?
since these two sides are
I'm
congruent,
gonna be honest.
then this is 4x plus 5. This 4x plus 5.
No, it's not even true.
Is it? Is X 11?
So 4 plus 5, 4 plus 5,
Yeah, but is it?
8x plus 9 minus 6 equals 6.
Wait. Okay. I think I
What's
did.
176 divided?
There's no way.
76. I got 84.
176. Hold on.
They're not.
No, because it's positive 4. So
Oh, you have to subtract. I'm stupid.
I have to shoot. Wait, no, I couldn't do it. No, this isn't
11.
I'm the same. I would do this. I would do the same way. Man. I just couldn't do that to our boys. There. I have too much
Oh yeah,
respect
she
for them.
doesn't. Yeah, she still has secondary math. It's just right.
Yeah.
Dude, but I think we're girls.
These are regulars.
I would not to know.
Down 3.
Never broke down.
Yes, I have. Yes, I actually.
Because we have our mark. Yeah.
I have never once put on.
Yeah, then you're back when you were you left it back.
Yes, I am. Dude, how did you know?
That's
How on earth did you know?
Okay, we're
I remember the whole year.
Pretty good fun.
That's me.
That's not.
Why would you?
This is so cool.
All right, show of hands. Who's still working on this? Anybody?
Did you like that?
That's not me. What? All of that? No.
Yeah, but like a quarter.
I have no friends.
I do have. I have
Sadly, no.
Wait, was that? You're talking about me? That's not me. That's not me.
Who is it then?
Oh,
That's it.
what's your name? Oh my
I've got to look up
All right. I want to make sure I type this so that you guys did not get. Let me just increase this, make it bigger, and then we can always. I can always write everything else in, but this one I wanted to make sure that you guys got. You guys can actually see it. Okay. All right. So let's take a look. So number 3. Number 3, it says, is any quadrilateral with 4 congruent sides a rhombus? And explain. So in this case, if opposite sides of a quadrilateral are congruent, it is a parallelogram. A parallelogram with 4 congruent sides ends up being a rhombus. So yes, it can work. And this could be said for a bunch of different ways. Okay, but I wanted to make sure you guys saw at least something. Is anybody writing this down? Okay. All right, so for number 4, big reveal. All right, so number 4, DF should have been 10. The measure of DFG should have been, let's see, 28. And EG, I got about 5. And that's with rounding. Anybody need to see those 3? Is he 6? Okay. All right. So in this case, I think there was an issue with 6. Guys, take a look here. You see this right here where it says F. It's not. I don't think it's in your companion, is it? The 5.6 right here. All right. Add that in, and then 6 should work out. Yeah, it's really hard to do 6 without that. Sorry about that. I forgot about that. Why they don't have it in your companion, I don't know. But if you add that, it'll work. It's Pythagorean theorem after that, Izzy. Do you still want me to do it?
No.
Okay.
Thank you.
All right. Let's take a look at number 12. Now, number 12, you should have gotten x equals 11. Does anybody need any? Are there any questions on that one? No? Are we good? Homework is on Delta today. Tomorrow it will be on Realize, but not today. All right. All right, that's it. Those who are watching at home, have a great day.